All easy, nothing to it. I got an interesting email after last time that I thought I would talk about. Won't embarrass the person that asked the question, but it was the top, this was the topic. Is that legal? Yes, no, maybe.
I think it is.
No question mark?
Yeah, but it's not.
I think it was, people want to know if it's what we want.
Aren't they?
I don't see no questions.
So it's a good thing we're talking about it, yes? So these two operators, this dereferences a pointer. It says, give me the value that this pointer points to. So star P is the value in memory at address P. This operator will give you, this is terrible accuracy. Doesn't look like anything.
Could be infinity.
Infinity.
Infinity, huh? Ampersand gives you the address of any variable. Okay, so this is a pointer, it has an address in it, and is ampersand x an address? Yes, it is. This isn't possible, of course, in Java, but there's more to the world of computers than Java, and you want to know this stuff. Yes, it's perfectly legal. It is perfectly legal. That's a pointer to. So can I do this? I've got y now. And does that change the value of x? What does it do?
You
Do you
change
find
it.
mine confusing, or are you guys bored with it?
Isn't it 4 on the stack?
Confusing,
We're
okay.
never bored.
Okay,
Whether
You
spells
start
and
setting the
mutants.
address.
so we have the system stack.
The 4 is on the stack, right?
We have an x and a y, because if you declare a local variable in a method, and they're all in methods, right? I mean, if you're writing Java, what code do you write outside of methods? You don't. I mean, you have class level variables that are declared, but you shouldn't assign them things there. Essentially, everything goes into methods. You have x and y. So x is an integer.
2.
It's got 2. That's easy, right? X also has an address. We don't know what it is, but we could find it if we wanted to. This you can't do now. It's not possible. You can get to the 2, but the address of where the 2 is, you cannot. In C and C++ you can. So we've declared now another variable, and this variable is y. And it has an address, let's call it CDE. And there's an assignment statement, the address of x. This is what it looks like. Y has an address and the contents of that address, both of which are addresses. So y has an address, it's located at location CDE in memory. The contents of y, ABC, is also an address. That's what makes it a pointer. Its contents, it's an address. That makes it a pointer. So, this set y equal to 4, what would that do?
Change that.
We would change
The
this
content. Right?
to 4. The compiler won't let you do that. This is a mistake. You don't want address 4. You don't know what's in address 4. So that is a mistake. What about this? Does that change x to 4? That changed X to 4.
Yes.
Yes, dereference Y. Get the address of Y and go there and get the 4. Yes, it does. All right. So the email question I had was this. In star P, that's a pointer, right? Star P is a pointer. Okay. Not a pointer. All right, which is it? Is star P a pointer or is it not a pointer? You follow me? What is star P? Star P is the contents in memory. So if star P points to a 2, then it prints 2. So how can these two symbols be different things? In fact, they are. The first one's a pointer and the second one is not. Stated another way, both of those are pointers. They're both pointers. P has an address in it. All right, this looks very strange, doesn't it? Star P and P, and they're both exactly equal, they're pointers. Now this can be confusing, I understand. The problem is, how could you declare a variable of type pointer without the dereference? How could you do it? This is dereferenced unless you're declaring it. So when you declare it this way, you're declaring the pointer. When you use this, however, it's not the pointer, it's what you're pointing to. I know it's a little confusing. But if you stop and think about it and kind of reverse engineer this process, P is an address that points to something, star P dereferences it, that will get you the value at address P. Then how else could you declare it? So we have the same syntax for both the pointer and the value it points to. All right. Clear as mud? Okay or not okay? Star Z, pointer to an integer. Z equals Y. Is this okay or not okay? Okay. Why? Because Y is a pointer. Star Y is what it points to. Now you can chain these bad boys. But what would happen if we did this instead?
That's not okay.
Is there such a thing?
Well, the address is the address.
Yes, there is. So the question is, does Z get ABC or does Z get CDE? And that's the difference between the two. Z equals Y. That's the contents of Y, which is an address, which is ABC. The first one, however, is the address.
CD.
So it's the wrong kind of thing. Now, older compilers will let you do this. The problem is it's a double dereference. It's a double dereference, which may be confusing. So let's simplify just a moment here and look at how this goes. This is okay. It looks funny. And you probably would never do this unless I made you on the test, right? But can we follow the chain? We have Z now. And what does Z contain? The address of Y, CDE. And this has an address itself, NO. Let's make something up. All right. If I want to print out 2, can I use Z? Yes. What do you want me to write? Well, if we print Z, we're going to get CDE. And if we print star Z, we're going to get ABC.
Sorry.
So we print star, star, Z. So remember, the declaration has to be what will get you that value if you print it. If you print star, star, Z, you'll get the value, not an address. So that's what you have to have here to print that value. Questions? All right.
Oh.
Did I hear someone?
Yeah, how do you get the value of 2 with star star Z? What happens? So you go to
star, star, Z. So
So-
go to Z, take the address and do reference. That's 1 star. The second star, we take the address and do reference.
okay. That's it.
And there's the 2. So we go to Z and we fetch CDE. So we dereference that. And when we do reference CDE, we get ABC. And if we dereference ABC, we get 2. So when we say dereference, what we mean is go to that address and take what you find there, which in this case is another address. So you go to that other address and take what you find there, and it's a 2. And these chains can continue, though it becomes pointless after a while. And star, 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 E equal and C. Is it legal? Yes, it is. So if you print star, 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 D, you get the 2.
You get the 2.
So this is a chain of pointers, so to speak. Now, can you think of a time when you would have star, 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 D? Would you actually do something? If you have a multi-dimensional array, you can do that. A 3-dimensional array, I have used one once. I got my head handed to me by my professor. He said, what were you thinking? 3-dimensional array. That's ridiculous. 2D makes sense. We all get the rows and columns thing. Well, what's the 3rd dimension? Well, I guess that's a stack sitting in that cell. But beyond that, it just gets crazy. But yeah, you can do that. Okay. Good. So, what are we talking about today? All right, some preliminaries I want to talk about so that you can get started. How do you open and read a file? How do you do that? Okay. So, several things here. First, it's a command line argument, just like it is in Java. ARGV, and then whatever the numbers, it would be ARGV1 is what it would be. That is the name of the file. So So how do you open and read files? So I'm going to give you some canonical ID cookie cutter code here to do that, because it's about, this isn't about learning C++. It's one of those, okay, I know how to open and read a file, how do I do it in C++? Oh, okay, I see. And then you move on. So you will need to have imports. Now note that we talked about this, and we're going to write in a few minutes the anatomy of a class. We're going to build a couple of simple classes and see how to do this. But there are two files you have for any class. You have the headers, the H file, and you have the implementation. The headers go in the H files. That is the includes. Don't put them both places. You just want to put them in the .h file. All right, so there's certain assumptions here. And this is in the actual implementation, which is the CC file we will do. So in your H file, you're going to have to put the streams. So we'll talk about that in a minute, but essentially you need IO stream. But you won't include that in the .cc file. You'll include the header for your class and you grab it that way. Okay. I'm F string in. Alright. String. Line. Couple of things. One, you don't need the keyword new. There's no reason to do it. None. In Java you have to, but here you do not. We declare input file stream, IF stream, in. So that is an input file string. We're not going to make it. It already exists. It's on the stack. Then we have a string lowercase s, not capital. Class string exists, of course, in C++. And in some cases, you're going to use the C++ string class. In other cases, you're going to use C-style strings. You cannot avoid it. We're going to have to use both. Okay. So we'll say open method in the file stream. File name dot C underscore. So the file name has to be a C string. If it's not a C string, it won't work. You read it as a string, you have to convert it. This is how you take a C++ string and turn it into a C string. These are methods to do that. This open takes a C string. Now what's the difference between the two? Well, C++, the string class is an object, and I think we're all familiar with strings in Java, and it's not altogether that different. However, in C, there is no string class. What you have is an array of type character, C-H-A-R. And so a C string is a pointer to an array of characters. And that array of characters must be null terminated. If it is not, it's not a valid C string. And there are essentially two ways that you can tell how far to go when you're reading bytes in a string. Either the string itself knows how big it is, or there's some kind of sentinel at the end that says this is the end of the string. C uses a sentinel at the end of the string, which is a null character or a zero. A zero. The character zero. Okay, so that is this character. That is this character. \0. If you don't have the backslash, then it's hex 30, which is not null. So it's also numeric 0. There's no meaningful difference. Now C++ has null. They It exists, but not as part of the language. It's a macro. And it's capital. It's capital because it's not part of the language. The zero is not. Okay. So we open this, we pass in the name of the C string, and then a switch. IO string, IOS is the IO string, and then a double colon. The syntax looks funny, you'll get used to it very, very quickly. The double colon is a single token. It is the scope resolution operator. It says the in member of the iOS class or entity. So it's a scope resolution operator. When you write your classes, you will need to use them. Okay. So this simply says, open the file for reading. Now, you want to check and make sure it really worked. If not, in. Throw file parse exception. And then passing the string could not open. The file. So this is a simple test to make sure it succeeded. In Java, you would probably do something like if n equals null. Because null is 0, you could just say if it doesn't exist, if it is 0, then throw an exception. If it doesn't exist, it's 0. With me? Confused? Yes?
Is it available or in after the string
I in. It's a switch. There's in, out. So there are different ways you can open a file for read, for write, for read-write, for sequential access, set the pointer to the start, concatenate, set it to the end. So there'd be different switches. This is the simplest, is just read only. Now notice here, so we've got the test to see if it worked. And if it didn't work, then it doesn't exist. So if not in. And again, this is the way it's done in C++. Do not put if n equals null. It's not done. Remember to use the conventions in the platform you're writing for. And if you don't, there's only two reasons. One, you're a troublemaker, or two, you're clueless. Which one do you want your boss to think you are? Therefore, follow the conventions that go with this platform. The other thing I would call your attention is we have throw, file, parse, exception, and where's the new? No new. Do we need it? Did I make a mistake and leave it off? Not a mistake. No, we don't need it. There's a profound difference here that you have to get used to. You can declare a variable, even an object, without new. You can do it without new. And in fact, you should. There's an issue here. Java has an automated file or garbage collection, and C++ does not. Therefore, if we had said, throw new file parse exception, we would have created memory on the heap, and we're obliged to destroy it. We're obliged to clear that memory, and we can't. Not easily. Because once we throw the exception, we're back somewhere else. So you have to explicitly delete that exception to get rid of it. If you use the keyword new. Anything you create with new, you have to destroy. We'll see in a minute. C++ classes always have constructors, but they also have destructors. They also have destructors because if you created memory, then you have to give it back. You have to destroy it. So again, there's a profound difference in the way this is done. If you allocate something on the stack, then when you hit the end bracket of the method you're in, that's popped off the stack and it's gone, and you don't have to destroy it. You don't have to get rid of it. Therefore, if you do it this way, as soon as you leave, it's gone, and you don't have to do anything. When you hit the end bracket of a method, it's popped off the stack and gone. However, if you allocate it on the heap, and it lives on the heap, and finishing a method, hitting the end curly brace in the method, doesn't change anything on the heap. Therefore, that memory continues to eat up space until you free it explicitly. So one of the problems with C++ code is the fact that you can have a memory leak. And how would a memory leak work? Well, let's say you do this. Obviously, when you throw an exception, that's going to end up terminating the program. But it wouldn't have to, but this is a good example. We throw a new file parse exception, we create a new object, and we don't destroy it. So if we call this repeatedly, every time we call it, we lose memory. And eventually, we run out of space in the heap. There is no more space available. It's all used up. Except we can't get to it anymore. In Java, the way this works is the JVM keeps track. So if you have something like this, let's say void food. And inside food, you say person p equals new person. So you've made this new object on the heap to do things. When you hit the curly bracket here to end method food, the Java virtual machine will say, wait, p is gone, because remember this gave us two things. We have the stack, and we have p. That is created where it hits the separation. And then on the heap, we have the actual person. So when we hit this end curly brace and we leave this method, this is popped off the stack and it's gone. It's gone. It no longer exists. And the Java virtual machine will go through on a certain cycle, so many quantums of time, and look, and it says, look, I don't have anything that points to this object anymore. Nobody points to this guy, so we have to garbage collect him and get that memory back. In C++, there is no automated garbage collection. Therefore, if you did this in C++ with the keyword new, then your person sits on the heap, you exit the method, you can't get to this memory anymore. It's allocated, it's in use, but you can't get to it. You have no references or pointers to it. It just eats up space for nothing, for no benefit. This is a memory leak. And if you call that method again, there's another chunk, and then another, and then another, and eventually you'll run out of RAM. Or you'll end up paging yourself crazy. Because what happens with modern operating systems is when you run out of memory, it starts putting it on the hard drive. So you have your RAM on the hard drive, which is a terrible situation. It's extremely slow. It's like 1,000 times slower. All right. What happens in this scenario, however? Let's talk C++ now. And I say person P, and on the stack, my person P, there it is. There's no heap involvement at all. I hit the curly brace, it's popped off the stack and gone. So, allocating and deallocating memory on the stack is far more efficient than the heap. Far more efficient. Therefore, this runs contrary So what you Java programmers know what to do. You need to break that. Be aware that this is the right thing to do, and putting new in there is a mistake. Because how are you going to get it back? Yes, Kim?
Was there any purpose to using boolean C++?
Well, there are times when you need to. For instance, if you're going to allocate an array, but when you're writing the code, you don't know how big it's going to be. If you don't know how big it's going to be, the compiler couldn't possibly rope out space on the stack for it. Therefore, you have to use the key. Other than that, the stack is better. It's better. So you should avoid using the keyword new unless you need to. There are times when you absolutely have to, like when you don't know the size. Yes?
So for if not and doesn't the if take a boolean, so how would that work?
Sure, that bears repeating. It takes a boolean. Well, that's what Java programs are used to. And so you would say something like, if n equals null, then it wasn't created, throw an exception. Okay, but null is not part of C++. That doesn't exist in the language. There is a convenience macro, NULL, all caps, anything 0. So you could say, if n equals null, capital NULL, then nobody does, nor should you. What is true? For numeric types, true is not 0. But 0 is false, right? Okay, if it's null, then it's numeric 0 and it's false. Therefore, the contents of n will be on the stack. You can look at it. You go and you look at it, it's either a 0 or it's not. If it's a 0, then it doesn't exist. It's null. It was not created. Therefore, you have if 0, throw out the file and parser exception. And if it's not 0, then it worked. Different concept. Yes?
I was just wondering, why do we not need a semicolon?
Where did I forget the semicolon? We open. We do need it. Yes. All right, let's finish this. It's not hard. We're almost there. And it should be familiar. So now we know it exists while not in .eof. So this EOF method returns true when you're at the end of the file. So while we're not at the end of the file, do. Now another thing we have to talk about, get line. Then do something with a line. So there are several forms of this getLine method. And note that there's no dot operator here. We don't have n.getLine, though it does exist, or that's not what we're using. This getLine is in STD, the standard algorithms, standard methods that come with C++ that are not part of any class. If you don't use using namespace STD, then you would have to put STD : getLine. Note, as I said, there are several getlines. This does not belong to a class. So this is very different from Java. You will never see something like this. What they're doing here is avoiding the awkward, ugly syntax that we see in Java. This predates Java. It does. But the Java equivalent would be something like class name.getLine. And you wouldn't have an instance, and the getLine method would have to be static. So you have things like integer dot parse int, math dot random. These are static methods. They're in these classes. Well, C++ thinks that these things don't go in class, so why make an artificial class to contain them? All right. Do something with it, and then close. Finish up, close, straight, file. That is how you read a file from disk. Questions, anyone? Behind the bag can go on the floor, just so I don't forget them their tests I have to N dot closes the end. So inside the while not N dot EOF. Get line, the string, and then this variable line here. So here, line gets something new every time, and you do something with it. Yes, Nick? Lowercase. Lowercase, yes.
So when you go back to the menu,
I don't follow you.
like, when you do get lines, you go to the next line.
Yes, it
You have
does.
to go back to the menu.
It sequences through one line at a time. There's this concept of line pointers. This exists the same way in Java. And the first time when you open the file, the pointer is before the first line. And then you grab it, then it moves down with every call for this till you get to the end. So that when you come to the top of the loop, it says n.eof, there's nothing more to grab. And so it has this file pointer idea. Yes?
So here we really are using the standard names.
No. I mean, this is just how to open and read a file. Every file you write should have using namespace st. Should have it in there. It matters here, right? We'll see in a minute. But you have a CC file. There is no reference to the standard. Without it, this wouldn't compile. This would cause problems. All right. So the best way to read these in is to use a vector. We'll talk about that. But I want first to turn our attention to anatomy of a class. So I want to start with something really, really simple here for you. So I have class student. So this is a student. You have a name, a red ID, a level, and a GPA. All right, so let's write this down and talk about it one piece at a time. Class student. All right. The very first thing you want to use is a method. So this is the .h file. This would be the file with the student. .h. Now the file name need not be the class name. This is not required, but it's a very, very good idea. In Java, class names have to have the same file name. So, we start out with the first line, pound sign. F and F. IFNDEF. If not defined. So this is lowercase pound sign IFNDEF. Now we're going to define a symbol by convention for all other cases with an underscore before the H. If not defined, student underscore H. Again, We could put food there if we wanted to, but you shouldn't. You could use symbols and that's what they are. Yeah, then define it. I'm saying define. What's going on? We want to avoid situations where we have multiple includes. We don't want to include student in more than one place in a project. We want to prevent multiple inclusions because that causes all kinds of problems. So we create this symbol, capital student underscore H. That's a token symbol, and we define it. And so if we have another count include student dot H, then the very first line is if it's not defined. Oh, it is defined, skip it. Everything is buried inside of this if index. So if it's not defined, define it. If it is defined, then skip the whole thing. So this prevents multiple inclusions. We'll do this for every class. It's important. Here includes. Anytime you're writing a pound sign, this is handled by the macro preprocessor. The preprocessor does all these natural things for you. You create your overall executable image, your final code to compile. This student class will be included only one time because of the macro process. Okay, include. So all you need. You can include these in many files if you need to not worry that you need to come back. What happens is you won't be included more than once. Include IO string. So it might be the case that you have multiple classes that use IO string, but you only want one instance of it included. So this will prevent multiple inclusions. Alright, so these are system-wide libraries of routines. You don't include the string class when you say string S and you get compile it. So you have to include the libraries, but these are system installed libraries rather than your stuff. Using namespace standard. Not section. Alright, so this is how every class starts out. And now we have class. Student. Yes.
So you said that you don't have to worry about multiple includes.
Right.
So you have the middle class of teacher, and you would have done both of these as classes, and you don't only include for student and
Right.
only include one of them, because in both cases, only the first time it runs into the student underscore H or teacher underscore.
Right, when it's first encountered, it's pulled into the context and it's available to every class in the project. But all of these system-wide files are designed the same way. With string, it says if index string underscore H. So make sure every class has this to prevent multiple inclusions. Now the Java compiler works on this independently. If you do multiple imports, then how much shows up? Well, if they're duplicates, then you're not going to get them. That compiler handles. That was a simplification of this process in C++. Class student. So this is the only place you have the class definition. Open bracket. Now then, we have separated. We have to separate into public and private here. Public. Colon. And then your public methods. Okay. Well, constructor. Student. Right. Now, unlike Java, there are no variables here, only the type of text. It's not string S, it's just string. Color type. We have a semicolon, there's no open close brackets. Student. is name, red ID, level, GPA is what they're going to be, but they're not labeled that way, just the type. Now you have the various getters and setters. I'm not going to write them all down. Void, get name. That name, void, set name. Now I put these camel things, but it's not usually done. And going that way, I'll understand that it will generally be get underscore name, set underscore name. More methods, however you need. The idea of getters and setters should be familiar to you. Private. No, yeah, lowercase. So it matches the public. You have the public section and your private section. String. These are your class level variables. String. String or handcover level. And float. So now whatever other classes or methods you might need go there, you must prototype them. Now this isn't the case in Java, but in C++ it is. You cannot use a poly method unless you previously prototyped it. You can't put them anywhere you want and they will be found and used. They have to have been encountered by the compiler before they're invoked. So these will be stuffed into that space before the CC file, so they will be there, declared and ready to go. But you have to put a prototype before you compile. Okay, so you may have private methods and they have to be prototyped here. Then we have into the class and the semicolon. Remember the semicolon. And then this is the if and f defined end of the if. So all of this will be skipped if the first thing fails. It's not true. So it's not defined, it is defined, skip. Questions? So this is the anatomy of the class. This is what it looks like. Public and private, this looks a lot like an interface. Looks a lot like an interface, except you never have private methods and you don't have variables in the interface, which you do here. So far, so good. Just different, not terrible, right? Okay. Now then, the implementation goes in a CC file. So now we would have student dot CC. This is the actual implementation of this class. All right, there is no open close bracket. What we have in this file is a collection of methods. It doesn't matter the order. However, we don't want to put other things. All right, so we can include any of the strings we might need. Particularly if you refer to them here, but you're not referred to in the H file, IO string. We didn't refer to this in the H file, did you? Well, I have it there. And so it does no harm, it will not be included. You can, we put them in the H file and not here if you want to. It's as if they're sunk in and dropped right here. Okay. Then your own H files. Include student.h. So you put quote marks around the ones you wrote. They're not system-wide installs, they're yours. And they're in the current location. Student.h. Okay. Always using namespace. Yes. All right. So methods. Student. Student. Double colon. Student. This is your constructor. String. In. String. ID. Int. Float. So you have the assignment statements. Name. Red ID. Level. L. And I'm going to have a name class here. Now notice that we have not declared name at ID level GP in this file at all. It's not declared there anywhere. It's in the H file. These are class level variables. When you hit this using our include student.h, the contents of this are taken in place right here. So they're all in scope and all visible. Okay. So we've got a sequence of methods now that we will implement string get name. Okay. So we will say string student. You need the class name and then the double colon to say what class it's part of. Now you could actually, I hate to say this, somebody might be tempted to do it. You could put implementations of other classes besides students in there. Seems like a bad idea, but you could. So every method you write has the return method, void, string, int, whatever, except for constructors. Now you need not always write a destructor, but if you've allocated memory in the class, then you need to. For instance, suppose that this isn't class student, but is something else. And you say it's a data structure of some kind, and you're allocating an array on the heap dynamically, and you have to free it up in the destructor. So a destructor would look like this. And it would go typically after the constructor, though there's no requirement about it. The little tilde means the destructor. The destructor. So that would destroy So you want to free or deallocate any memory that you have allocated in there on the heap. So don't try to free something that isn't freeable. You can't remove something from the heap if it's not there. So it will crash your program if you try. Questions? Not too bad. All right, I'll post this example. I will post this example for you guys on the class website. Now, I want to talk about, I have enough time, good. I want to talk about vectors because you're going to probably want to use them. This is kind of an introduction to what we call the standard template library. The standard template library consists of a set of functions and algorithms, containers, transformation algorithms that was designed primarily in HP. And like Java, they take a type. And we're going to dive into this a little bit more later, but I'm going to give you the introduction to it. And in particular, I want you to see that we use pointer code and anything else to work these. In some cases, you have no choice. So these are built in, and a good source that you guys can go to see the documentation. Well, it's a reasonable source. It's not overly friendly. Nothing about this language is overly friendly. But C++.com has write-ups of this stuff. And then they want you to have to buy another text. There's a lot online, so you can use that as kind of a reference. All right. Where is my vector? So, when you create a container in Java, you would do something like this. Vector. Look familiar? So you guys know string is what's going in the vector. That's what's being stored in the vector. This is our Java. And it's a parameterized type. C++ is quite different. This is vector, lowercase v, string, lowercase s. And it looks the same, but it's not. There's a complete difference here. With a Java class file and parameterized types, which I'm assuming you all understand, yes? You did these in 310, did you not? You know, linked list, brackets, integer. E, you remember the E thing, the E's and the T's? Yeah. The E's and the T's, elements and types. All right. Then Java has what's called type erasure. When you compile those to class files, you don't recompile them if the type's different. Therefore, the same class type has to work with everything. And so there is type erasure that's actually replaced by type object, capital O. That does not happen in C++. Rather, Java tried their best to make it work like C++ and make this transparent. But this is completely different because if I do this, well, first of all, I couldn't do that in Java. And in C++, int, not integer, int. You get two different sets of vector code. The actual type compiled to int at compile time. So if you have 5 different vectors, different types, then the vector code is 5 times inserted into your executable. What you have is custom code, so that The int version refers specifically to int, string version to string. It substitutes, so there's no generic object in your code, rather there's the exact specific type. This leads to slightly larger executables, but it's faster. There's no runtime figure out what it is, cast it to something, because the native type is right there. So you compile it as a standalone executable of the exact type that you need. All right, so the compiler will prevent you from putting anything in here that isn't that type. That's what you really need to understand. If you do this one, and you try to put a 2 in there, it will fuss at you. And you say, no, can't do it. Now in Java, we have vector v. Can I do that in Java? It's not an array. It's not an array. You can't do that. It won't compile. You might think you ought to be able to, but guess what? It's Java. No, you can't do that. Oh dear. So you have this little at 0 element at. You have to use helper methods, right? You with me? It's not an array. You can't use those short methods. So in C++, you can. It's because C++ has operator overloading. That is, we can redefine how the operators work. Well, this is written for you. You don't have to redefine anything. It's a container class that comes with the system. But know that the square brackets are overloaded. They have been written. Now the behavior is pernicious, so you should be very careful. Consider this. You may do the index as a read only. Otherwise, it's very dangerous. It will blow up on you. The thing about C++ is there are not a lot of safety nets built in. Java's loaded with them. The difference is like you take a Ferrari, you rip out the seatbelts, remove any airbags, get rid of the safety cage, go racing. Or you take a souped up Lexus with everything. Which one's safer? Well, of course, I want to be in the Lexus when I run off the road. Please. Not the Ferrari, because you're getting killed in the Ferrari, right? There's no safety device at all. Now, which one's faster? Well, all that safety for what you waste something. It's going to cost you something. Taking out those airbags, is that going to lighten the car? Sure it will. Make it faster? Probably. Do you wish you hadn't had a wreck? I would. Sure. Well, that's kind of the difference here between Java and C++. And the Java world says, you guys have been driving Ferraris and killing yourselves. You got to stop doing that. Everybody's got to start driving a Lexus now. Okay, well, that's the idea. Well, great Ferraris, and there's no safety. So, vectors are actually stored as arrays internally. You don't need that information, and how it happens you don't care. But it's contiguous memory. That does matter. And if you run out of space, they'll resize themselves. They will. However, the square bracket operators are not overloaded to do that. So suppose we have a vector of size 10. Then could I do this? Yes, I can do that. Does the compiler do that? Like the least bit? Is legal syntax? Can the compiler tell that the underlying
data structure. Isn't that big? No, it can't. Understand with Java, you've got this Java virtual machine that runs your program for you. You don't have that with C++. You have this executable that's going along, doing what you asked it to do. And if something bad happens, the operating system will crash your program out to the command line. So, what is after that vector in memory? Because the tail end of that vector, whatever it is, you just wrote to it. Okay, that wasn't part of the vector. It was something. You don't know what it was. How much harm did it do? You have no idea. It could be a one-off variable that you already used and you're not going to use again, then no harm, no foul. But you can't know that. Therefore, this is something you should never, ever do. No. You may read using those brackets, but not write. It's dangerous. Having said that, understand that square brackets were not designed for this function. That's not how you do it. There's a method. What you do this is using that pushback. This is the method. So what you need is pushback and popback to remove from the end. You may read it in index if and only if you know it's there. If you don't know it's there, then you haven't helped. So you push back. Alright, some useful methods. When you make this, you can reserve the size. Reserve. For instance, if you know how much space you need, you can ask for it. The way this works, some of you may have been in my 3-2 class on made you do resizable arrays. If you run out of space, then you create a new array twice as big as the old one. You copy everything from the old one to the new one. You destroy the old one by setting it to null, and away you go. Okay, that's an expensive operation. So you want to minimize the number of times you have to loop through and copy everything into a new, bigger array. So that's how you keep from running out of room. You make a new array, copy everything over, destroy the old array, and move on. It's not inexpensive. So access, reading something's big O of 1, but resizing the thing is bigger than, because you have to copy everything in the structure. So the general heuristic is it will be created, and it depends on the implementation. It's not specified. Rohan, it used to be 10. I don't know what it is on the numbers. But assuming it's that, so it makes a vector of size 10. And it runs out of space and it makes one of 20 and copies everything. And it runs out of space and it makes one of 40 and copies everything. And it runs out of space and makes one the size 80 and copies everything. Okay, far better to say reserve 100 to start with. More efficient. Now, when you're going to read a source code file, you have no idea how big it is. So if you reserve 100, can you go past that? You can. It will go ahead and continue to resize. But this says, my new vector I just made, make its size 100. And making the array is cheap. Copying all those elements is not. So doing it at the beginning, where you're guessing the size. If the guess is too conservative, that's fine. It will save you a lot of copy. All right. Pushback. Tack it onto the end. This is the safest way to do insertions into a record. Do not do it any other way. Yanks the last thing off the end. So if you're using it as a stack, for instance, this is how you would do it. Okay, you ready to go crazy? Back. Straight. Double fold. The accessor methods for these vectors now is using iterator. This is how it's done. This is not the way that we do things in Java that it is here. So if you want to print everything, of course you would use an iterator in Java as well, though you don't just as likely loop through it. Could you loop through it and print them all? You could, but no one does. This is not the way it's done. Plus, there are other things that you cannot do without using iterators. For iter equals v dot begin. Iter not equal to v dot end. Iter plus plus. See how. Oh my goodness. What in the world? Pointers. Pointers. V dot begin gives you a pointer to the first element in the collection. V dot end gives you a pointer to the element after the last element in the collection. So when you are equal to v dot end, you have run off the end. And what you're pointing to is not in the vector. You with me? So let's draw a small picture here. Vectors always occupy contiguous memory, as I have said. Dot begin. Returns pointer to the first element. Dot end returns a pointer to the slot after the end of the array. It's invalid. You cannot dereference it. You will get garbage. So if you want to go backwards, you do minus minus before. So you would do iter equals v dot end minus 1. You've got to go back. It points off the end. You with me? I know the syntax is strange, but an important point to be made here. Part of the reason why we're doing this. Years ago, we had some high-level discussions about what language we should use in beginning computer science classes, and there was no broad consensus on it. But Java won. There was a feeling that it's an easier language, and the students might make better progress with an easier language to start with. And if you hit them with this in 107, it might not end well. And in fact, we taught C++ in 107 or 108 for, I think, maybe 18 months. And the failure rate was so high, we stopped doing it. And we switched to Java. That kind of ended the argument, and the failure rate was so high. So the point I want to make here is I think we made the right choice, that we have taught you essential ideas of computer science using a language like Java. But there's a big chunk of your education you haven't found, you haven't discovered, you haven't learned yet. And now's the time. This seems horrible, but it is not. The idea of a pointer is a simple concept, right? I mean, you could easily say, okay, what's a pointer? A pointer is a variable that holds an address, the address of the data that you want to see. A pointer to an integer has the address of where that integer actually is. It's simple to say, it's simple to describe, but the implications are anything but simple. So now we're adding to your education, giving you another view of this broad concept of computer science that is enormously powerful, will open up all kinds of possibilities. So it's worth the pain. It's worth the pain. So I would like you to dive in and